Okay guys, so let's get going. And week 9 we were distributes was done, and then we went for cluster and DRs. Okay, so we'll continue with the cluster features. And so in the cluster we have HA, DRS, FT, EVC, and loads of other features. So we had a talk about the HA features one by one and what those features are for. We'll continue with that. And yeah, my machines are up. And what kind of pressure they're built on me? 22.7. Oh, so I will check if I have the connectivity to my VCSA. And yeah, I normally Mr. Small receiver message 1, 2, 3, 1, 2, 3. Okay. Now, there's that message written on the top here. I'll just try to click this manage your licenses just to have know-how that what's going on. I'll just close this one as well, and I'll expand the screen as well. So it's evaluation, nothing got expired. Okay, we're good. And I'll go to menu here and go to home. Basically I need to go to home, hosts and clusters. Excuse me.
Amir, one thing I changed my resources on my EXSI 2 and 3. I made the RAM a bit more higher, like I made like 5 GB each, and then all my errors have disappeared. I restarted all the VMs and even the EXSI host, and all the errors have disappeared. I've been green.
All the errors have been disappeared after you've increased the RAM?
Yeah, I increased the RAM on the 2 and 3.
Okay. Well.
And I restarted my VCSA also.
Oh, okay. Yeah, last time after introduction of HA, we didn't restart that, and it's still
right.
Well, let's see if they remain disappeared, because they do reappear as well. But if
yeah, that's what. So whenever it's trying to deploy VCLS, that's the time it is issue happening. It's saying resources not enough, but just not deploying OVF template and all. You should be 93%. It's done everything, and everything is green as of now.
Oh, right, nice. So yeah, that would make sense that the resources are not enough, and it would not be able to do some of the tasks in the background. So definitely that makes sense. It's our network. So
yeah, we have limited resources in our networks, means in our work environment.
Yeah. Okay.
But as of now, I'm green. If you want, you can share my screen.
Okay, that would be good. So A6i2 is 6.1 here for me, so it's already good, and or better, not good. And well, A6i3 is actually 4 GB, and both of them are giving me errors. Yeah, so that's a good idea if your screen is available and you have no errors. So I will just troubleshoot my errors later then.
Okay, let me just share it. Just a minute.
Okay. Till then, I'll just restart my. Okay, I'll shut down my A6i3 and then. Shut down guest. It will properly shut it down. And E6i1, I will shut down guest, and then it will shut down the VCSA as well. which is if I properly shut down from here and then so I'll go from outside as well, but we can shut it down from our management interface as well. Administration. This will log out. So there's a long way to shut it down, and there's that quick way. I'll just go with the quick one. Shutdown guest would properly shut down the inside machines, and then this one. Okay, memory 4 GB. I'll make it 5. So that is 653. I'm increasing the memory and turning it on. 651 is shut down. I'll just power it on again. But then I have to remotely connect to this and start the VCSA as well.
Right.
So what happened? And
yeah, you want me to share your screen? Yeah, just a minute.
Okay.
Share.
Thank you. Okay, so hopefully everyone's able to see it better. There's a layout option. Use tag side by side. Full screen view. There's a full screen view as well.
I'll just make it full screen. Just a minute. Just try to move this bar from here. Yep. Okay. Where the full screen option?
No, actually, I did the full screen here on my side.
Okay. Okay.
But also, yeah, there is up here. Are you seeing my screen? No, I'm seeing your screen, right?
This is my screen.
Yeah. So hopefully everyone is seeing my screen, and then your screen as well. So yep, this is good enough for us. But I have no full control here, right?
How do I give you full control? That's what I'm wondering.
Yeah, this WebEx has that issue. Normally, there's you can just right click on my username and then check the options there if you are able to see my name in the WebEx.
Just a minute. Let me open up this. It's funny. I don't like WebEx. We have not used much of. Yeah, we normally use Teams.
Yeah. Oh.
Mm-hmm.
Teams and then Teamviewer. You mean Teamviewer?
No, Teams.
Oh, okay.
Microsoft Teams.
Oh, just for represent.
Yeah.
Yeah. Okay. Here, yeah. That normally, I'm also it's supposed to be a very very easy option, but this is really strange that. How come? So when you right click my name, it doesn't. My name means the Netplus College. When you right click the Netplus College,
let me try again.
It doesn't offer any kind of on the top. Yeah. The WebEx options, at the right or on the top. Oh, you don't see those options there.
Just a minute. I hit those options. That's the reason.
Yeah, it's okay. So I will let you know then what to do. Yeah. So, or we can go for Teamviewer. You have Teamviewer?
Make presenter. Okay, you're done.
Oh.
There you are.
You got it? Now I'm the presenter. Well, so I...
Okay, and then I'll share my screen.
Okay.
Okay, so now you should have control.
No. So, well, what I can do is I can just let you know, then click here and there, but that's not very...
If you want, I can download Teamviewer.
Yeah, Teamviewer, if you could quickly...
Yeah, just a minute.
Thank you. While you're doing that, I'm just going to quickly try to get my machines up and running and check out if my error is gone now. Fresh. It's going to kick me out. also connect to ESXi01 quickly to go inside and I'm going through my ESXi just to check that if VCSA is up.
It's been a long time.
Oh yeah. So I powered on my VCSA, yeah, now it's going to...
Okay, I have my Teamviewer on.
Oh,
If you want, I'll give you my partner ID.
Thank
Yes.
you. Yep. You make...
28284.
Okay, let me share then my screen back so everyone's okay. Yeah. And I'll start the team viewer. Sorry, yeah, my team viewer is starting now, and as soon as it starts, I'll just ask you to. You can also put that in chat, or now my team viewer is starting. Okay, yeah, so what's the...
Yeah, it's 284.
Remote computer. So that's the partner ID, right?
Yeah, partner ID 284.
2FO.
288. 284.
Okay. 284.
142.
142.
078.
078. Connect. Either your partner isn't connected to the internet or your partner's team viewer isn't running yet. Please tell your partner
It's running.
Your team viewer is started?
Yeah, yeah.
Please tell your partner to check his internet connection or to start. Really? 284-142-078.
Right?
And
Oh, sorry. I'm sorry. My bad. 819.
Sorry.
819.
819.
189.
189.
822.
822. Okay. Enter. Alright, password.
X.
Yeah.
Lowercase x.
Yeah.
4.
Yeah.
X again, lowercase.
Yeah.
D for David, lowercase.
Yeah.
And 58.
Lowercase, right?
Yeah.
58?
58. Yeah.
Lowercase as well. I'm just kidding.
58?
No, I'm just kidding. So, okay, so we're back. Woohoo! Okay, thank you.
Welcome.
And okay, so I'll just put that up there, and I am recording all that. Okay, good. So I'm just gonna close this sign here, and I'll make this screen full. And we were there on TeamViewer session has timed out and will be closed. Are you kidding me? TeamViewer? Okay, I'll just connect again. Your license limits the maximum session duration to a partner service. Immediate reconnects are blocked. Okay, I'll grab your ID and remotely connect from another computer. Sorry guys, this is all... So I have a team viewer from my other desktop that is starting. Okay, my remote desktop it has. Oh. Okay.
And so the internet is not there on your own remote machine.
Yeah, I'm remotely connected, but it's not connected to internet. So I'm gonna just shut down quickly everything. So and restart the machine. Wow, it's get bad and bad. So through LAN I'm connected to this machine. I'll just, oh really, update and restart. No. So it's going to restart the machine there, and my laptop actually I've been connecting through this, so it has been so we were Teamviewer knew that this is going on, so they blocked my machine now from using Teamviewer. So I'm remotely connecting to. I'll pause the recording here. Resuming. Alright guys, so we're back now after some struggle, and I just need to connect that other laptop to the power, so no more surprises when we start. Okay. Okay. So guys, we were talking about this NY cluster, and then why all this machine related stuff happened. Okay, so we're on the cluster, and so the cluster is created in on the data center level, and we have when we click the cluster, so we should always go to the summary first and check that if anything is being communicated there, any error that is showing there. So okay, yeah, I'll just expand my screen, and yeah. So other than that, we need to then, since there is no error showing there, that's wow, and E6i2 summary and E6i3 summary. So normally, well, they will load, and then the summary area is just where we can just quickly check the errors. If we go to the cluster level, then there is that configure. And in the configure, we have Vsphere Drs and Vsphere availability, which we have been talking about, and many of the features of Vsphere HA we've been talking about in the last class. Failure conditions and responses. So mainly the admission control will really go for capacity reservation, which we have discussed in last class, that admission control will, okay, let me just go there, and I'm going to click this edit for proactive HA, and failures and responses, automation level, remediation, we talked about that. And then there are providers, which are if you are going for any third-party providers as well, some third-party software that you want to connect there, but it's not showing all the responses. I'm just going to click cancel here. I'll go for the actual Vsphere HA, this one. Yeah, so failure responses, we talked about all this, that when the virtual machine, if this failure, PDL, permanent device loss, or APD, all paths down happened, or host isolation occurs, or if the virtual machine VMware tools stop sending heartbeats to the HA, then how do you want to respond in response to all this, these disasters? would you restart your machine? Would you just simply power off your VM? Or you would disable it, that the powering off option, and simply go yourself and investigate and then decide, oh yeah, I think we should restart this. So it's up to you. And then we talked about admission control, and there we fully disabled it. And why? Because we already have very less resources, 32 GB. Even, well, 64 GB would be okay, but 32 GB is obviously also less. So that's why otherwise it was on by default cluster resource percentage, and this means that one machine worth of resources we cannot use anytime, because it's keeping that much resources for the disaster recovery or capacity reservation. So that's why we need two machines, actually, not one machine worth of resources actually reserved and not be able to use. So that's why we're in our lab only disabling this admission control. Otherwise, obviously, in your production environments, this would be our job saver feature, admission control, that it would just at least reserve the capacity of one machine worth one physical hypervisor worth of virtual machines. So admission control, and then heartbeat data stores, we also talked about that. Okay, I'll select one of those. That if the heartbeats are going to the HA, and through the HA to the master hypervisor from the slaves hypervisors. So heartbeats, slaves are sending, or slave ESXIs are sending heartbeats to master ESXi. But if for some reason master ESXi is connection is frozen, and vCenter cannot take information from master ESXi, so vCenter can also take information that hey databases, are you receiving heartbeats from all the other slave ESXi hypervisors? And if you had selected this option, the log files will note the heartbeats coming from all the slave hypervisors as well. So that's vCenter would know this the other way as well, if the master hypervisor for some reason is not communicating and reporting that all slave hypervisors are okay. So that's heartbeat data store. And then advanced options we talked about before as well, that it's going to, well, as the name says, advanced options. So any of the default behavior of the admission control, or HA actually, can be changed by asking the VMware tech support the code to put here if you want changed anything here. So this is what we were talking about, HA. I'm going to press OK here for HA, because I need to go to DRS as well, because they both work together. And we've talked about the triggers as well, that when do the triggers happen, when does HA kicks in. HA kicks in when the physical host is down and the virtual machines have to be restarted to the other hosts. When does DRS kicks in? DRS kicks in when there's a degradation of performance on the working ESXi host. So if the ESXi host is down, DRS can't do anything. ESXi host has to be up for DRS to do anything. And what does DRS do? Simply move virtual machines from low performing host to high performing host. That's what it does. How does it do that? We're on Vsphere Drs here, and it is on as well. It's a good idea to turn on HA and DRS, all the main buttons there, and then we can just turn off or on the features inside each. So Vsphere Drs, if I go here to edit button, so you can see that there is automation level, and there is migration threshold, and then there is the rest of the options. So automation level, what does that mean? It says fully automated. And what are other levels? Oh, there's a manual, there's a partially automated, and there's a fully automated. So if we first go to the manual, and it says DRS generates both power on placement recommendations and migration recommendations for virtual machines. Recommendations need to be manually applied or ignored. Okay, what are we talking about here? So DRS in manual mode will be only recommending stuff. It won't be doing anything. That's the first thing. What would it be recommending? It would be recommending power on placement. Okay, we'll discuss that. And it will also be recommending, hey, please migrate administrator, VMware administrator. Yes, you. No, it's not going to say yes, you. So anyway, it will just recommend that migration of virtual machine. Please, can you migrate from E6i2 to E6i6? I just analyzed, and E6i6 has more CPU and RAM available. E6i2 has much less CPU and RAM available. So these are the analysis it will keep on doing, that which host right now, every 5 minutes actually it's going to analyze, and which host has to offer how much CPU and memory, and which host is offering less and which host is offering more. So it keeps on analyzing all those. So DRS generates both power on placement recommendations. Okay, what is power on placement? As the word says here, and let me, oops, okay, so hopefully you're able to see my full screen, where I am, like my laptop screen as well, where now I am opening the diagrams. So hopefully everyone is able to do that. Sarfraz, you're able to see my screen?
Yeah, I can see it.
Okay.
Yeah, one more screen, right?
Yeah, because I'm looking at your screen, so I was thinking that if the audio is okay and everything. Okay, cool. I hope the rest are also able to see that. And okay, so I'll copy the diagram and open it. Okay, so placement related stuff we need to just talk about. What is power on placement? Power on placement is simply if a virtual machine shuts down. So there are suppose virtual machines on different hosts, and they have their virtual disks on different LANs here. Okay, for that I need to actually create LAN-based data store here as well, and then go back to the virtual disk here, and virtual disk for this machine here. So what happens is that if the virtual machine was to be restarted, or had to be shut down and restarted for maintenance purpose as well, so in that case I'll put vdisk here, yeah. So if the machine was restarted and or shut down and powered on, so power on placement just means that DRS will check that, oh, this machine is starting. Okay, let me, before it starts, let me check right away which hypervisor is the best match in terms of CPU and memory availability. Suppose this is having a big application called SQL, and this is having a file server here, FS. So in this case, SQL Server is a heavy application, and it requires a lot of CPU and RAM. So it normally DRS has an analysis of which machine has been using how much of CPU and RAM. So when it's about to power on, mainly DRS sees that which host has more CPU and RAM to offer, and it starts this machine there. Whichever host has less CPU and RAM at that particular time to offer, the DRS just keeps away from that host. Suppose this virtual machine was on E6i2, and then you shut down this virtual machine for maintenance, or had to restart this machine for maintenance. Now when it is about to power on, Now DRS will think that E6i2, okay, it has just 10% CPU and RAM available, while this one has 40% CPU and RAM available. So, okay, last time it was on E6i2, but now I, the DRS, see that 40% CPU RAM is available on E6i3. Okay, I'm going to start this machine on this host from now on. Right? From now on means, well, at that particular time, whichever host is providing the more CPU and RAM gets to be selected to start the virtual machine. So power on placement just means that which host is suitable, more suitable, and let's start virtual machine there. And we don't care where the virtual machine was running before the restart or shutdown. So the best host to start the machine on is power on placement. And if we go back here, so that's manually it's gonna simply suggest, oh, you're about to restart the machine or power on the machine. I suggest you start it on E6i11, suppose there was one. So it's up to that VMware administrator to really look at those suggestions and act on it. And but that's what power on placement is. And migration recommendations obviously are whichever host is supposed to offer more CPU and RAM, just migrate to that. So it can only suggest. But that's the manual stage where it only suggests. What is partially automated DRS setting here? DRS automatically places virtual machines onto hosts. So one of the tasks it will be doing automatically now, which is power on placement. So now it's not gonna only suggest, it's going to actually place the virtual machine to the proper host. Proper means the host is actually offering the most CPU and RAM. It will just start it on that. So it will do that automatically from now on if you select this partially automated, while it is still recommending migration. So that's partially power on placement is automatic now, but migration is still just a recommendation. And obviously the fully automated is that placement is automatic and migration is also automatic. And it just simply sees that oh, this host has less memory, okay, let's move it to, if any other host is offering more, to that one. Suppose others are also not really offering much, so it doesn't move actually. So it's making intelligent decisions there. Migration, so this is automation level, right? Then there is migration threshold, which is conservative up to aggressive. So conservative means less frequent V motions, and aggressive means more frequent V motions. And it's in the middle by default. And suppose we go for from aggressive to, there are 5 levels, aggressive to conservative. So what is, if I go to the aggressive, and we will actually do that now and check it out. So but if you go to the aggressive, so it says here DRS provides recommendations when workloads are even slightly imbalanced. Workloads are slightly imbalanced. What does that mean? Workloads are slightly imbalanced means that there is a slight chance of the other host offering a little more CPU and memory. It will simply vMotion right away. So when the vMotion happens, yes, there is a slight freezing on the screens of the end users, and if the network is very good, it's not really bottlenecked even in peak hours, so customers would not feel anything, and they are working on it. The clients are working on it. They're remotely connecting, while underlying DRS is simply moving the machines from vMotioning the machines from one host to another host to the third host to the fourth host if it is on aggressive mode. So if we go ahead, it says here DRS provides recommendations when workloads are even slightly imbalanced and marginal improvement may be realized. For dynamic workloads, this may generate frequent vMotion. So obviously that's going to be your virtual machine would be in last 5 minutes in E6i2, and next minute maybe it could be on E6i21. Suppose it's a large environment and having 200 hypervisors, so your machine would be moving per minute even if there's other hosts that have very good, or it could move after an hour as soon as it sees, oh, there's still another host that has even more CPU memory. Okay, let's move it there. So it keeps moving. But the guarantee here then is that the machine will always have best performance available, right? So it will be always on that host which has the most CPU and RAM to offer. If that is a critical machine and there were 2,000, 3,000 users connected to it, and a lot of work going on, and they still see no issue in performance, so that is good, as long as the vMotion does not create, lots of vMotions do not create a lots of freezing as well, even a second of freezing. Other than that, if I drag it down to fourth level, so they normally don't give very solid numbers here that what changed. They just say in Word, and the DRS provides recommendations when workloads are fairly balanced. So before they were slightly imbalanced, and now it is fairly imbalanced. The word fairly, or this threshold is suggested for environments with bursty workloads. So this is just that maybe, little, suppose previous one was if there is a slight difference, it just uses the word slightly here, and that could be maybe 5% more CPU and RAM is available, move it. Here it says here fairly, and this means in the documentation VMware says that there are some mathematical algorithms going on in the background, and that simply decides that okay, when do fairly start and when fairly kicks in. So but documentation just says that you can check out, suppose there is only 10% or 15% of difference between the current CPU and RAM and the next one that is offering that. If it's a bit more RAM, CPU and RAM is offered, then it will decide to vMotion. And if you keep going down, so it just keeps changing here to moderately. Now the word is moderately here. DRS provides recommendations when workloads are moderately imbalanced. It's saying here recommendations, but it acts on it right away. So first it recommends that I see this much difference in the CPU and RAM. I am vMotioning this machine now, or these machines. So DRS provides recommendations when workloads are moderately imbalanced. This threshold is suggested for environments with stable workloads. Default is this, which means that you can again go for percentage. So if the CPU and memory is 30% more available, if you see that much, or 25% more available, then it's going to migrate vMotion, otherwise it won't. And that gap just keeps on increasing when you go towards the conservative side. When DRS only provides recommendations when workloads are extremely imbalanced, like you have 40-50% more increase when you see in the CPU and RAM in any other host. When it's this much difference, then only it decides to vMotion, otherwise it won't vMotion. So it's extremely imbalanced, right? It could be also 60% more CPU and RAM when it is available, only then it triggers. Otherwise 10%, 20, 30, no, it's not a lot for me to decide to vMotion. And then the final one is conservative. DRS will only apply recommendations that must be taken to satisfy cluster constraints like affinity rules and host maintenance. So I may have talked about affinity rules before as well. It's an upcoming topic right after DRS, in fact. So affinity rules just means that you put a rule there. Suppose one type of affinity rule is CPU to host affinity, where VM to host affinity, where VM must not leave a particular host. For example, that VM is running a graphics software or blockchain technology, or cryptocurrency mining is going on, and that virtual machine is on a physical host that has a GPU hardware, right? The processor and graphics card, graphics adapter are supporting GPU, so a graphical processing unit, right? So in that case you would want to create a VM to host affinity. What does that mean? this VM is connected to this host and you can't move it. So DRS, please do not vMotion this machine. So if that kind of situation is there, that there's an affinity rule created, or host maintenance, the host is about to go maintenance where the host has to move away all the virtual machines on it. If the virtual machines are powered on, you cannot put the host on maintenance. The host will say, hey, can you move all the machines, powered on machines there, or shut them down, suspend them, or vMotion them. But there cannot be a machine on top of a host powered on that is about to go to maintenance mode. So when this kind of condition is there, then only it tries to recommend moving the machine. Affinity rules, if they are there, it can't actually move the machine, but for host maintenance, it has to then move the machine. So in that case only, when it has to, then it will decide. You have to manually, in the case of affinity rules, you have to manually remove the rule. We're about to create those affinity rules, so you'll see that what they are. But if they have to move, then only they go. Otherwise, they don't decide anything by themselves. So if it's on, conservative. So what I will do is, I will go for fully automated on the top, which was already by default fully automated, but aggressive was on in the middle. But now I'm gonna go for aggressive mode, full aggressive mode as well. Why? Because we can actually check if it works. What works? That you would be able to see that the virtual machines will be migrated automatically without us touching it. Like what I'm gonna do is I'll just put all the machines. I will have to power on all the machines first of all. Then I will put them all on one host only. We'll just check that if wherever the machines already are in majority in the host, the rest of the machine we will put it on virtual machines on that host. So then DRS will automatically check that, oh, there's the other host has more CPU and RAM available, so it's going to start migrating right away the virtual machines automatically without us touching it. So that's what we want to see. So that's why I'm going to put this on full aggressive. While, well, we're going to check that, but we can just check other features as well, which is predictive DRS. Enable predictive DRS, and what it says in the information here is that in addition to real-time metrics, DRS will respond to forecasted metrics. So it's gonna forecast, oh, this host CPU RAM seems to be going down, 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 down. Oh, it's not available anymore. Like it's the usage is going up, 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 up. So it sees that trend that last 2 hours the CPU RAM was 75% available. In Now it's just 80%. 75% not available. Now it is 80% not available, and it keeps on going to 90% not available. It's just getting busier. So it forecasts that, and at once, since it sees that trend, it simply vMotions at a forecast, and it hasn't reached that level where it is supposed to do, but it forecasts that. Forecasted metrics provided by vRealize Operations Manager. Now, if you enable this option, you must have another expensive separate VMware software called vRealize, and it's a one-stop monitoring application that really gives you in-depth proactive monitoring alerts, just like Microsoft has SCOM, System Center Operations Manager. VMware has vRealize, which is a big monitoring and automation software. Only forecasted metrics with high confidence. It has to be high confidence as well, that we're sure that now the performance will degrade. Only then it acts on it. With high confidence will be considered by DRS to balance the cluster's workloads prior to predicted utilization spikes and resource contention. So it will simply vMotion prior to predicted utilization spikes. Before it happens, it simply tries to do that with solid monitoring and specs there, information there, monitoring information. If it's solid and it has high confidence, definitely it's going up. So that's it. Then it moves before it actually happens. You must also configure Predictive Drs in a version of vRealize operations that supports this feature. So if you have if your company has purchased a license for vRealize for older vRealize version or edition, obviously it may not have Predictive Drs capability. So a newer version of vRealize supports that. So we don't have to really do that because we don't have vRealize operations separate big software. Virtual machine automation, enable virtual machine automation, and that is override for individual virtual machines can be set from the VM overrides page. So, well, here, yes, virtual machine automation is enabled, which just means that automatically just whatever DRS decides for it, just implement it. But we have another option. It doesn't move actually in the background where you can do VM overrides as well. Then there is additional options here, and wow, really? Okay, I just have to first press OK here, and then I think it might let me see the rest of those options. So fully automated and fully aggressive is there, and I'm going to press O and K. Oh, what happened? It's not responding. So Sarfraz, are you able to press OK? Okay, maybe we stayed here for too long. ESXi has a host memory usage. Okay. It's okay. So yeah, we can just go back to. So yeah, I'll just I'll go to that area. Yeah. Okay, thank you. And what the only change I made here is the full aggressive. The rest I did not click, and I'm just gonna press OK just on that. And now DRS is supposed to be working fine. How do we really check it if the DRS is working fine? First of all, I can go on the cluster level where we are already. I'm going to click that, and on the summary page, cluster and then summary. Here, there's a Vsphere Drs related information also showing. If I click that, Vsphere Drs. So there's a cluster DRS core, and then there is a VM DRS core. So how their performances are and where they are in terms of normally it gives a score. And then there's a view DRS settings, and it shows the view all VMs. Other than that, if I go down, cluster resources, tags, cluster services, and if I just expand the cluster resources, yes, EVC mode disabled, we're good. So I'm gonna stick to Vsphere DRS here, and I'll go for view all VMs. So VMware DRS core right now, it's not supposed to show any because all the virtual machines are turned off. So I'm going to be powering on first of all the virtual machines, and second thing is that I'm going to put them all on any one host, so DRS could see this and at once take its actions, which is to balance the whole environment. And how would it balance? It would just try to migrate or remotions the machines to other host, So there would be balanced usage going on between the two hosts. I'm going to go back to the one more thing that I need to show is the monitor option inside the monitor. So there are issues and alarms, there is a performance overview, and Vsphere Drs, there's a recommendations here, and we can just go for run DRS now. So DRS normally recommends according to what it sees there. Oh, there's more CPU RAM here, or this is right now our virtual machines are not power on, so it will not give any, which I will be turning on. So if I go down to the monitor and then under the Vsphere DRS section, the faults, there's no fault here as well. History, if we go there, so normally here, DRS, whatever DRS has been doing, normally starts showing up here. So what I'm going to do is I'm going to first check that if I go to the VM01 and check the summary here, so it is on E6i2. VM02, it is on E6i3. VM03 is on E6i2. VM04 is on E6i2. So most are in E6i or on E6i2. Now when
VM01 has the operating system installed.
Oh, okay, that's also good.
Yeah.
Cool. So the thing is now, as soon as they power on, remember that power on placement feature. So power on placement feature will get triggered now, and as soon as they power on, it's going to decide that which host is better suited for which virtual machine. So we might see, as soon as the 4 machines are started, we might see that they will be on different hosts according to how DRS decides that. So I'm going to right click on VM01 and power on. So VM01 was on, okay, E6i3. Well, it started on E6i3 now. VM02, while it is shut down, is on E6i3. So I'll start it now. So if power on placement is needed, DRS will decide that. Oh, see, it was, when shut down, it was on E6i3. While we power on placement feature, simply place it on E6i2 itself. So VM03 is on, when it is shut down, it is on E6i2. So it depends on DRS will keep it there, or the DRS will simply move it to the other one according to its own algorithms. So while shutdown it is on 2, and while powered on it is still on 2. Okay, and the only power on placement happened on VM02 here. So I'll just go for while shutdown. VM04 is on E6i2, and when we power on, if DRS decides, it still decides it on 2. So VM01 is on 3, VM02 is on 2, okay, VM03 is on 2, and VM04 is on 2. Okay, only one VM is on 3, the rest of the VMs are on 2. So I'll just change that right now and put everyone on 2, and then leave it to DRS, fully automation, fully aggressive mode, to decide that which VMs go to 3 again. So only VM01 is on 3, the rest of 2, 3, 4 are on E6i2. So I'm going to right click and migrate this VM01 as well to 2 to make the environment unbalanced, right? So I'm going to migrate, because DRS is all about balancing the environment. So it's going to decide then that this is not fair, everything's on 2. So let me just choose which one goes to which one. So I'm going to put it on 2 as well, E6i VM01, which is on E6i3. I'm going to put it on E6i2 now. And yeah, the rest is okay. Distribute, switch, high priority motion, yeah, finish. So every virtual machine is supposed to be on 2 now after this migration happens. Whoa, what happened? But their migration also happened for the other machines. VM01 is on 2. Yes, we did that. Okay, I hope everyone's on 2. VM02 is on 3 now. DRS just simply took action right away. I showed you 2 or 3 times that VM02 was on 2. VM03 was on 2 as well. It moved it back to 3. It just balanced it right away. Oh, all other, it moved to 3. They are empty machines, as Sarfraz said. The first one is the having the operating system inside. The rest of them are empty. So in order to balance, DRS simply moved the 3 machines to E6i 3 now. They were on 2, while I moved it to 2 from 3, the VM01. So DRS fully automated and fully aggressive, really is aggressive, and in 7 they have improved it. 6.5, 6.7, it was not that aggressive. It would slowly do that. Here, amazing, it just right away, it takes the decision right away. So well, if I go back to monitor for DRS activities, and that's for, if I go to cluster level and monitor and then history, so you can see that history was not showing anything before. It was empty, and now history is showing that what DRS did. And what DRS took decision was E6i 2 to move to 3, VM02 to move to from E6i 2 to 3, VM03 to also E6i 3, VM04, and so these are the decisions at these times taken about. So place also, 3 migrations happened by DRS, and 4 placements also happened by DRS. Like, DRS decided that, okay, which machine, now they're starting, let me think that, let me decide which machine should be placed or started on which hypervisor's memory the machine files should be loaded. So the place is also showing here. So that's pretty good. It's so automated that if suppose the VMware administrator does that all the time and is sitting doing nothing, then it's so automated that people say that VMware administrators are then can be fired as well because it's working so good. Well, that's just a joke, but definitely, if we leave it on that automation, then many of the tickets will not be coming your way, and then they will think that, hey, do we really need an administrator? Obviously, we need one, but do we need 3 or 4? Okay, anyway, depends on the big environment. Now, Vsphere Drs, we talked about those options of fully automation and fully aggressive, but there are more options as well. If I go back to configure, cluster, configure, and then DRS, and then I go back to edit. So, fully automated, fully aggressive. Normally, yeah, well, in a production environment, you don't have to really move the machines here and there for best performance. Best performance is always the goal, but if it is working fine on this third level here, it's okay. Or you can move it to fourth level, that or maybe on whenever you're getting more of degraded performance related complaints or tickets, then you can move it to 4, and you're still getting those from critical machines at least. Then you can go for aggressive as well for the peak times when really everyone's working and they really want to go ahead. So Other than that, there's additional options we're talking about. We're seeing here, and those are VM distribution, enforce a more even distribution of virtual machines across hosts in the cluster for availability. May see a degradation of DRS when utilizing this setting. So what it says here, just enforce a more even distribution. So this means that suppose there are 5, or suppose there are 10 virtual machines which are actually not consuming a lot of CPU and RAM, and there are 2 virtual machines that are consuming a lot of CPU and RAM. So DRS can decide that the 2 machines that are consuming a lot, let me put it on one host, and those which are not consuming at all or very less consumption is there, those 8 virtual machines, I'll put it on the other host. So in terms of the CPU and RAM distribution, it seems okay. Yeah, so it's balanced. The 2 more consuming are only on one host, and the 8 less consuming are on one other host. Overall, they are using pretty much the same level when we count collectively. So, but what about if the 8 machines are on that other host and the host goes down? So all 8 machines will have to be restarted, and there would be still a lot of users using those 8 machines, and they will all be effectively disconnected, and it has to be restarted. So it says here that enforce a more even distribution. Even though the 2 machines that are using heavy are placed on another host, still from the 8 machines, please move 2 more here, making it 6 on both sides. In case the host actually goes down, then not majority of the machines are affected. Obviously they will restart, but that takes time, and end users are still effectively disconnected. So the better option would be to go for, well, it depends on VM distribution. Is not, I can't say it's a better option, uh, but it seems like it's good. So according to your company compliance policies and discussions, you would go for that. But in some of the big environments, you would not see this enabled. So it's not about even distribution, it's about better performance for virtual machines. But yeah, then you're taking a risk that if many of the machines are all collected on one host and it goes down, the restart, there is still a downtime even though it's small. CPU overcommitment enable, and that is if you overcommit. So control the CPU overcommitment in the cluster. This setting allows the admin to set a virtual CPU to physical CPU core ratio limit, vCPU to physical CPU for all hosts in the cluster. So this is just saying that the machine should not overcommit. Overcommitment ratio should be that one vCPU, suppose I click enable here, and you go for certain options here. So one vCPU to one physical CPU would just mean that enough processing would be received by the virtual machines. When you are running critical virtual machines, then you can do that, one vCPU can be actually connected or to one physical CPU there, and physical CPU by not by the whole socket. It would be obviously 8 core physical CPU, you have maybe 16 core, maybe 32 core CPU. So one of the cores can be actually assigned to one vCPU also. That would really guarantee that the processing that is needed is actually received there by the virtual machine's vCPU. So this can be done on if there are very critical machines are there, and you have a lot of CPU power, physical CPU power as well among the hosts, underlying hosts there. Scalable shares, enable scalable shares for the resource pools on this cluster. So normally shares are, it would be, as we talked about in resource pools, that shares are actually the priority. So you have given 40,000 shares in resource pool to, suppose there are 3 resource pools, marketing resource pool, 5 virtual machines, and sales resource pool, 2 virtual machines, and maybe also admin resource pool with 10 virtual machines. So whichever resource pool has more shares, 50,000 shares for marketing resource pool, 40,000 shares for sales resource pool, and 20,000 shares suppose for admin resource pool. So whichever has more shares will get more attention by the DRS, that okay, oh, you want more CPU and RAM, let me see the shares. Oh, you have more shares, okay, so what do you want? And okay, this much CPU and RAM, okay, let me provide that to you. So scalable shares, just it's a feature for whichever machine has more priority, DRS will simply decide that. And whichever machine requires more CPU and RAM, the priority will automatically increase in the background. That will trigger attention. Hey, DRS, pay attention to me first. So it's all automated in the background if you enable this option. Then there's power management, which, well, we need to be careful about that. Although it's a feature here, so basically it's going to save your hydro bill, your electricity bill. And how does it do that? So if we enable that, so it's on manual, and it is also having automatic and aggressive level. But what it does is that it's going to suppose you have maybe it's a big company first of all, then you would be using that, and they say that there's a big bill coming, they're charging us a lot for you electricity usage here. So what's going on here, why the hydro bill is so much? And then the boss says that, or CEO says, management says, please can you control this, our physical servers are being used all the time. Are they being really used all the time, or during nights there's less usage or no usage at all? So can you control the hydro bill? So this is power management is for that purpose. And what it does is that you have suppose 100 E6I machines, ESXi, right? So those 100 E6I machines, and those 100 A6i machines are running day and night, 24/7, 365. Now hydro bill comes a lot, and then they're saying, okay, do something about it. So you devise a plan that, okay, if you enable that, what will happen is that DRS will check, especially the DPM will check that how many physical hosts have virtual machines that are not being used at all. First of all, at night many virtual machines may not be used, right? So when they are not being used, and then it will analyze also that if I move all, suppose there are 100 hosts and 25 hosts, it checks and analyzes that 25 hosts virtual machines I can move to the rest of the 75 hosts, right? And because 75 overall virtual machines are not being used right now, or not that much, so even if I migrate or vMotion 25 hosts virtual machines to the rest of the, and distribute it among the rest of the 75 hosts here, so it will all night, it will be good. So it analyzes that, it vMotions all the machines to the 75 hosts and distribute among them, and then shuts down the 25 hosts at night. So shuts. And it's not at night, it's about whenever the usage is so low that it's okay to move all the virtual machines, vMotion the virtual machines to the other host, and still the virtual machines have enough CPU and RAM. Because they're not being used, so they have enough CPU and RAM. So then it will shut down the host. In the morning, it will see that the pressure on the virtual machines on the 75 hosts is increasing until it realizes, oh, okay, so there are so many users connected and the CPU and RAM on all 75 hosts is 25% left, and then, oh, now it's 20% left. Okay, let me just send a remote wake on LAN command to all these guys. Okay, wake up, all the hosts, you are needed. And the hosts are supposed to, in a perfect environment, the hosts are supposed to start. In the patching weekend, we normally pray, please don't let any host just not start, and then we are on the run on the weekend as well. So anyway, this is kind of a risky thing, that if the host has some issue, because it is running 24/7 365, there is a possibility, obviously, that something breaks when they restart and they don't restart at all, or something. OS doesn't restart even if the host starts. There's some issue there. So anyway, it sends the remote command. It is power on. As soon as they power on fully, then the machines are again divided back among all the 25 hosts as well as before. So DPM does all that. The only risky factor here is that, okay, every night it is happening, the hosts are stopping, and your monthly bill is now getting better and better. But if you also see that, okay, maybe there are new hosts, so they're good, but as the environment gets older, or maybe you had some older hosts that started breaking up, and you had to run in 15 days, one time you had to run and check it out, that which host did not start. And so you can just, according to that, you can just turn it on, or just configure it on manual recommendations instead of automatically just shut it down. And then so it would be aggressive mode here as well, and it could be conservative mode here as well for DPM. It's just a bit scary that if majority of the host, or 3 or 4 hosts doesn't start, so that many virtual machines are still on other hosts, right? Although they're running, and you just have degraded performance, a bit of degraded performance, that is. If more hosts stop, then you're in big trouble. So new machines, and if you've tested the remote command, that when they're shut down, wake on LAN, they really start. When you have done a lot of testing, then you can enable the DPM in that case, and be ready for if any machine breaks or any OS breaks when start, shutdown, start happens. Okay, so that's DPM threshold, and this is manual. So I'm just going to uncheck that, but that's the purpose of DPM, to save hydro bill by shutting down many of the machines. It's not that scary as I make it sound like. It could be good as well. Like for wherever my friends are, I haven't heard anyone enabling it, but because maybe they don't have all new machines, but obviously the companies would want that. Now there are so many data centers for Azure and AWS, and there are so many big data centers, so their machines are running 24/7 365, so obviously they need that mechanism to control the costs. And the advanced options again is that you can just add some code here to change the default behavior of the rest of the features here. So this is DRS, and I haven't made, I changed it back, you know what, for fun. I mean, like, not for fun. So it really keeps the environment fast. Like
Albert, just a question.
Yeah, sure.
You can have multiple clusters, right, in the same environment?
We can. So suppose you have 200
new machine running. Yeah, so if you have like 100 EXIs, 100 hosts on a new machine on a different cluster, do the clusters also have a DRS option?
Yes, like each cluster's DRS option is for that cluster only.
No, I'm saying that if I have one more cluster, like say EY cluster, okay, and I have some machines out there, and those are brand new machines, and I have enabled your power off option. Okay, and we go off. So do they jump to the NY cluster, or they will just stay in the TY cluster?
No, it's the EY. It will just stick to that.
Stick to that. I get it. So there's a jump from a cluster to cluster.
They're separate clusters. Clusters will work separate because there are disaster recovery features, sensitive features that might affect others. So no, they always are separately working, unless VMware has included that in the latest features as well. For now I know that they work separately.
Okay. Yeah, it's just a wild question. I just thought about it.
That's good. That's good that they can collaborate or not. So
yeah.
And aggressive. So I'm just putting on aggressive, the DRS, and I'll just keep it okay. That's the only change I made. Actually, additional options, no selection here. We don't need actually this one. Definitely we don't need DPM. And so automation, it's just on fully aggressive. I'll just still press OK here. DRs have been improved to such a level that it's simply does it right away because of out of its analysis that it has done, and it does analyze that environment every 5 minutes, that which host now is better performing, so I could move the machines. Because it's on full aggressive, we can expect the machines to keep moving. Our machines no, because we're not really using, there's no pressure coming to them, or the pressure doesn't change because the users went away or a lot of users came back. So otherwise it's kind of moving from time to time according to the resources being used during peak hours especially. Okay, we talked about DRS, and we talked about vSphere availability, and we have kept them all on. Obviously they are supposed to be on, but if you don't want any virtual machine to follow the DRS and HA rules, then there's a VM overrides here. And if I click that, VM overrides, and where it is, it's in the cluster, configure, and you keep going down until you see VM overrides. So VM overrides really lets you override on a virtual machine level that that virtual machine is not supposed to follow any of the DRS rules, and this virtual machine should not be affected by any HA rules. So in that case, you will go for, I'll click add. It shows the machines there. And if I select one machine and click next, so it starts saying override. So, well, suppose I don't want this machine to have be moving from one place to another, whatever machine I selected. So if I go disable here, so now at least DRS will not be able to vMotion this machine. This is also good where you want one machine to stay on that particular host, but we have affinity for that. That's a better way to stop a machine from being vMotioned from one host to another. But this is also another way that priority, VM priority here, VM restart priority override, next priority override, additional delay. So whatever you were configuring for every machine in HA, it can be, and in PDL, this particular machine, the failure response should be all others okay, don't touch, but here, or power off and restart, okay, that's also good. But for this particular machine, I want it disabled, or for this, I just want issue one. So anyway, we get the idea that override is that on a virtual machine level, this is a very good feature, that you don't want certain machines to be ruled by these DRS and or affected by the DRS and HA. So we can just then simply put those overrides for DRS, HA, and that's it. Yeah, DRS and HA features. So I'm going to click cancel from here. And then there is Affinity Rules. And before that, we already talked about EVC, Enhanced vMotion Compatibility. So that is just to mask the incompatibilities of the underlying physical processors if they are different, if they're not exactly the same model. So EVC is there. But now there's another thing called Affinity Rules. And when you have enabled DRS, especially when you have enabled DRS to let them move, the machines from here and there. So in that case, I will just put it here. So what I was saying was, DRS, it will keep on moving the machines, but maybe you don't want the virtual machines to be moving the way DRS is moving them. Suppose there are two machines that needs to stay together, and DRS is moving them away. So how does that happen, right? So I'm going to go for another diagram, and there, suppose you have the 4 or 5 or 10 hypervisors here, and these are suppose ESXIs. So there are two machines here, and those machines, 2, 3, 4, now there are two machines here that need to be together wherever they are moved. Which means, first of all, why what kind of situation requires this? First of all, what are we talking about? We're talking about affinity rules. And what are the affinity rules? So there are different types here. Affinity rules are that so there's a VM to VM affinity. There is VM to host and there's VM to VM non-affinity, anti-affinity, we can say VM to VM anti-affinity, and then there is VM to host affinity, VM to host anti-affinity. So well, these rules, and then there's a VM start and stop order. I mean, that's another one, VM start / stop order. I don't know why they put it in affinity. So affinity rules, VM to VM affinity just expects us to have the two VMs must stay together. That's VM to VM affinity. And what does that mean? So the two VMs, obviously, this is, you're telling the DRS on fully automated mode that, and full automated and full aggressive mode, that hey, these two VMs, so whenever you're moving them, you need to move the vMotion them together. They cannot be separated. While then VM to VM anti-affinity is, these two VMs cannot be together on one host. So there could be situations where VM must not be together on one host. So we're going to talk about that. And then there is VM to host affinity, that this VM must stay on that host. And the anti-affinity obviously would be, this VM or VMs cannot stay on this or these host. So there could be that. And then first let this VM start, then this, well, I can just go for then this, and then that VM. So what I'm trying to say here is that just a one-liner for all. So first of all, it says VM to VM affinity, and it is the two VMs must stay together. In what situation do we need that? Normally it is when you have load balancing, right? Or if the VMs are vMotioned on separate hosts, then one might get more CPU and memory and the other would get less CPU and memory. If they are getting different CPU and memory, that might affect the services they are providing. So most probably if they're providing exactly the same services, so one example would be, for example, load balanced, the VMs behind a load balancer, that you would want them to be together on wherever the vMotion or DRS vMotioned them. So if the two VMs are, there's a rule placed for those two, any two VMs that you decided for VM to VM Affinity. So DRS will respect that rule, and DRS will make sure that whenever the vMotion occurs, these two VMs, any one it decides to move, it has to move the other one as well. So you're just telling DRS, hey, these two VMs will stay together wherever you decide to vMotion them. So it will analyze according to two VM requirement for CPU and memory, not one VM requirement to vMotion. And the other one is these two VMs cannot be together on one host. So what scenario is there where you would need that? That's an easy one. It would be failover, right? Failover's cluster, when you're doing a failover, and it would be FT, when the virtual machine's fault tolerance is the feature name. So when active and passive VM, active slash standby. So one VM is active, other is standby, right? And somehow the standby VM on another host, DRS again checks that, oh, there's another host where there's more CPU and RAM. Let me just move this, whatever that VM is, to that host. And if then it checks the anti-affinity rule, oh, okay, so that host that I decided to move it to has its other partner. And the anti-affinity rule says no, don't get them together on one host. Obviously, for failover or active standby, if they're both on same host and the host goes down, both goes down. And the main feature of active standby is that they should be on separate host. If the host goes down in for active the services then failover to passive or standby. So these cannot be on when you're automating the DRS process, and it is supposed to be motion. Then you have to come down to these features, and you have to enable them as well. So otherwise, it will mess up a lot of services for us. This VM must stay on that host. So this example we have already talked about that if if a VM needs GPU and one host offers, then well, that's a scenario that only that host offer, or whichever host offers, that VM can only be on that host which has more physical components that the application of the VM needs. So obviously you won't allow DRS to move this machine away, virtual machine, from that host. And then this VM cannot stay on this host would be the same reason. Suppose there's a virtual machine with SQL Server database, and that requires a lot of RAM. Now, most probably all hosts would have the same configurations, but in case there are hosts with particularly lesser RAMs, in that case, you would have degradation of performance on the machines that really need that performance. So in that case, you would go for that this particular virtual machine, i.e. Database VMs on hosts with good hardware, right? So most probably the whole cluster hosts would be having same hardware, but normally it can happen that not every company can afford to have latest hardware, or in one go they can purchase $5,000 worth of 50 hosts or 60 hosts or 30 hosts. So every year when the budget allows, they purchase more. So sometimes there are from the same company, from the same vendor, but different hardware, a bit different, or newer hardware, and different hardware is always there. So in that case, these rules will help you keep the correct machine on the correct hardware, correct host. And well, VM start order is obviously that's the easiest one, that first this group of machines can start, then this group of machines can start, then that group. So you can actually add machines in a group 1, 2, 3, 4, and then start. We may have seen that before as well with VApp. VApp is exactly for start, stop, restart. So this is these are the affinity rules here, and let's try to check them out as well and configure them. Oh, so I'll just take that screenshot. Okay. Oh, is this? Oh, okay. This is mine. Okay. Oh, I also have to put. Okay, so here, what we can do is, when we are configuring affinity rules, yeah, so VM and host groups we can create, and then we can create the rules. For individual virtual machines, the rules are configured directly, and if you want to create groups here, we don't have a lot of hosts and not a lot of virtual machines as well. So you're going to see what's going on, but we're configuring now affinity rules. So first of all, we can go to the VM and host groups, and if I click that add button here, okay, add, and it says here, well, so there's type and there's VM group and host group. So first of all, you want to suppose you have 2000 virtual machines, and there are 10 virtual machines out of those that need to be always running on a specific group host. Suppose you have 10 virtual machines that are running blockchain or cryptocurrency mining application, or some graphics software, only 10 virtual machines. So, and you actually have 10 hosts here out of 50 or 60 hosts that have that kind of hardware, that have the GPU, processor, and adapter has a lot of RAM as well, display adapter. So you have 10 of those hosts, and 10 of those virtual machines actually want to always be running on those 10 hosts that have the proper suitable hardware. So suppose that's a scenario. So then you can create a group of those virtual machines which requires more GPU, and then you can add a group of those hosts as well that actually had that hardware, and no other host has that hardware, right? So then you come to groups, VM groups and host groups. So suppose it's we don't have any such hardware configuration or requirement. So, but just to give an example, GPU VMs, right? and GPU VMs, and I'm just pretending that if I go add here and there is VM0, 1 and 2, I don't need that group, but I'm just going for press OK. And then there's a, well, I'm going to press OK here, and then there is add button again, and we can go for host group here. We can create those, and that is GPU hosts. Suppose you have hosts with good graphics configurations there, and then you go for add, and well, we have just 2, so I'm just going to select that ESXi 2 here, press OK. And suppose that's 10 hosts here that are offering GPU, I press OK. So that's how we can create groups, but I'm going to show you where to use the groups when you do create them. There's an option where you can use. So this is not the action place, but the real action happens in VM and host, VM/host rules. So now if I go to rules, you may or may not need groups, but obviously for the host rules, if you have configured DRS with full aggressive especially and full automated, then you do need this affinity rules. So VM host rules, and I'm going to go for add, and you can see the options here. There's keep virtual machines together, that's VM to VM affinity, separate virtual machines, that is VM to VM anti-affinity, virtual machines to host, VM to host affinity, and virtual machines to virtual machines. So virtual machine to host has 2 options, VM to host affinity and VM to host anti-affinity. You will see that. And then virtual machines to virtual machines, that is just the start and stop priority of group of virtual machines. So first of all, if I go to keep virtual machines together, and I select that, and I go for first I can just name it VM to, you don't really have to give this name, just for explanation, clarification, VM to VM affinity, the way we understood that, and that's how VMware also puts in the documentation. And which 2 VMs should stay together all the time. So I'm going to click add here, and I can go for VM03, VM04. And suppose they're the ones that need to stay always together. And so then if I go ahead add again for VM to VM anti-affinity, now we don't have that many machines, so we're just gonna use the other group, which also we created as a group. So VM dash to VM anti-affinity, separate virtual machines, and so virtual machines cannot stay together in this case, so I group them together as well, VM01, VM02, and okay. And then the other type is, if I go add here again and go for the third type, virtual machines to hosts, so you can see already that the groups that we created now appear here. The host group appears under the the host group, under host group is the GPU host that we created, under the VM group the GPU VMs that we created. And now the options are here: must run on hosts in group, should run on hosts in group, must not run on hosts in group, and should not run on hosts in group. So what does that mean? Must run, obviously this means that this group of machines must run on this group of hosts. There is no other choice, has to run there. And if we go for should run, so this means that, okay, if those hosts where they're supposed to run, if those hosts are available, okay, then run on them, first priority. But in case they're not available, then okay, run for any other suitable one. So should is just a choice, must, no choice, has to run on those hosts, and must not and should not is the same case. So this is where anti-affinity, so whatever you're creating, you will go for that. Must run on host, so no choice, Obviously, some critical machines need to have those hosts. It's not, and some non-critical machines you can go for should run. So I can just choose here VM dash to dash host dash affinity rule, right? VM to host affinity. So GPU VMs, GPU hosts must run on hosts and group. Another rule I could create VM to host anti-affinity, right? So I could do that too, but this is the way to do it. So that's what we wanted to know. And if we press OK, so the third rule gets created. And then if I go for the fourth one, just to show what it offers there. So this is all about select cluster VM group, and the VM dependency restart condition must be met before continuing to GPU VMs. So or on restart for VM group. So if you have multiple groups of machines that suppose there's the first group depends, or the second group depends on the group of these machines to start first, right? Suppose these are two domain controllers in Microsoft domain controllers, and the rest are member servers here, right? So obviously the domain controllers must start first. Suppose there's patching going on and the domain controllers and member servers all need to be restarted. So we would restart domain controllers first when they're fully started and ready to authenticate and authorize. Then we should start the member servers and client machines later, because the domain controllers should be already logged in and ready to offer authentication and authorization services, and then the hosts and clients should start. The clients should start. So you can just put the first group to start as they may be the second group may be dependent on the availability and restart of the first group. So in that case, you can just put that virtual machines to virtual machines. So I'm not gonna click that. We don't have two virtual machine groups there. But what we did here was VM to VM affinity. You can see there's VM03 and VM04. So VM03 and 4 are supposed to be always together. That's what we are telling in Affinity Rules, right? While we have DRS enabled, which is ready to migrate because of the performance. So DRS must respect affinity rules, right? So 3 and 4 are supposed to be together according to the affinity rules. What I'm going to do is I'm going to move 3. First, I'm going to check that 3 and 4 are on the same host. Then I'm going to move or vmotion away any one of those machines to the opposite host, right? And I'll keep it there and see if DRS checks that VM to VM affinity rule is requiring that the two machines be together on one host. So I'm going to first check if they are on the same host, and if they're not, then already we're good. Then we can just wait for the DRS to do his thing, to take action. Otherwise, if they're on the same host, we're gonna just separate them and check if DRS respects the affinity rules or not. So I'm going to go to VM03 here, and in the summary, we're going to check VM03 is on E6i3, VM04 is on E6i3 as well. So I'll just right click VM04 and migrate it to E6i2. It migrated. Well, I was just keeping an eye on the recent tasks here, and I migrated away from this, and yeah, nothing happened till now. So well, we can just give it time until 5 minutes have passed, and then it checks again. The DRS checks again and sees that, oh, there's something wrong here. if it checks. So we're just putting it to test. Okay, so while this is going on, we were talking about VM host rules, VM overrides, EVC and IO filters as host options, host profile. Now we need to go for another critical service called fault tolerance, and then we're going to come back to the smaller options there as well. So we're going to start that. Okay. So before we start the FT, and we can just give time to this as well, we can just take a time.
I just had moved the VM4 back to EXSL3.
It just moved?
Yep, I saw the last one. It moved to back.
Oh. Oh yes, it's back. Man, it works like a charm. Oh, so how can I miss it? Where did you see that? In the task? In the recent?
Yeah, it's a task I saw.
So I missed it. Oh, thanks. That's a good observation. And yeah, so affinity rules are respected right away and followed right away by DRS. So that's very good. And these rules are critical if the DRS is on. And DRS is a feature is available only in the most expensive license. So obviously big companies would have that, and not a lot of companies would have that DRS. They can't afford to have that kind of expensive license. So when you have it, yes, there are some things that we need to take into account. Okay, so let's take a 15-minute break and then come back for the FT. So I'll just minimize this. That's 420. Resuming. All right. We need to talk about. Okay, so we talked about VM overrides as well, and we need to talk about the FT, fault tolerance. Okay, so let me also remotely connect. Okay, so fault tolerance is supposed to be for zero downtime, and it has zero data loss or no loss of TCP connections. So normally failover service, if you have configured the Microsoft failover cluster service, then also it is offering zero downtime and zero data loss. So that's the same for the failover service here as well. Vsphere fault tolerance provides instantaneous failover and continuous availability, zero downtime, zero data loss, no loss of TCP connections. This means that you're connected and end users are connected and the machine goes down or underlying physical server goes down, then still it fails over. The end user is not, well, other than the little freezing, they're not really affected. Okay, let me just check if I have remote connectivity. Oh, again, I don't have. Okay, so I have, well, I think I have to stay a little more. Well, I'll put this screen on the side and keep clicking on it. Okay, so here, fault tolerance, basically fault tolerance with primary and secondary VMs, there must not be any SPOF or single point of failure. Single point of failure would be when you're creating this. Here in VMware, active passive machines are called primary and secondary VMs. So now this diagram actually has server 2, which we don't have, so I'm just gonna show the whole thing, or well, I'll just show it on the other diagram. Right, copy. So about fault tolerance, that fault tolerance. So first thing is that the virtual machine that you, first of all, fault tolerance is for critical machines, right? So what I can write here is you can't just enable fault tolerance for every machine. So it is FD is for critical VMs only, because it creates a lot of traffic, and that's why obviously we need to create the VM kernel port for that too, and to have its dedicated IP address, and basically physical network is also dedicated. So FT is for critical VMs, and there is a primary VM, which is also called, we can call it active VM, or to which all the users are connecting, and then there is a secondary VM, and then there is secondary VM, which is also called standby / passive VM. So the primary VM is on one host and data store, while secondary VM is on whichever second host in the big environment, second host, and also second data store. So so this means that there should be no SPOF or single point of failure for these machines, right? So what happens here is that now if we create that virtual machine here for the active, so suppose this is the, okay, I will still create that data store, LAN-based data store here and here. Now if we have this virtual machine on E6i2 and this virtual machine on E6i3, and the first one is the primary or the active, So we'll stick to the VMware terminology, which is primary VM, and this would be secondary VM. So secondary VM, and the primary VM is so if we go to this, so primary VM's virtual disk would be on one data store. Obviously, when we do create the secondary VM or the passive or standby VM, so its virtual disk could be on a data store other than the data store where the primary virtual machine's virtual disk is. So when we are making sure that the data stores are different, that the for the secondary VM and the host is different, obviously then we're making sure that there is no downtime, there is no SPOF between the primary and secondary VM. When we say SPOF, so that is single point of failure, and that would be if we decided that the virtual disk could also, for the secondary VM, suppose we decide that that it is supposed to be here as well. And now if this data store if goes down, then we lose the virtual disk of both virtual machines, and the failover purpose is lost there if there's a SPOF or single point of failure between the two machines. So obviously they should be on a separate storage, separate network, separate virtual compute environment. So that is the host, and so that's what we would make sure primarily for the primary VM and secondary VM. If I go back to I'm clicking on that remote environment, so it does not. Okay, so here in fact, I'll just put that other diagram here in this slide and upload it. Okay, so fault tolerance, and let me grab from the documentation online as well. So normally they keep on introducing new features there. So Vsphere 7 FT. So I'll just drag this here. Fault tolerance requirements, limits, and licensing, and that is for the product documentation of 7.0. So it shows here 7.0. Now, oh well.
Amir, just your mic. It's loud. Disturbance is coming in.
Oh, there's a extra sound coming.
Yeah, there's like maybe some fan around you or something. Or some sound is coming. I don't know. Either I'm hearing it or everyone else hearing it. I'm not sure.
Okay, so yeah, there was another fan, pedestal fan there. So the old school. I'm on the old school. So okay, now it's okay. Better. Okay, cool. And okay, yeah. So we were talking about this, and I'm just gonna copy this whole link here as well. And let's go ahead. Wow. So Before using the FT, consider the high-level requirements, limits, and licensing that apply to this feature. Requirements: the following CPU and networking requirements apply to fault tolerance in Vsphere 7. CPUs that are used in host machines for fault-tolerant VMs must be compatible with vSphere vMotion. Obviously, we already talked about the vMotion that the CPUs should not be incompatible. They cannot definitely be of different vendors. They have to be same vendors and same families as well, same generation as well. And if fault tolerance is okay with those conversions, which are okay, with which vMotion is okay. So in terms of CPU, vMotion requirements of CPU are good for fault tolerance as well. Also, CPUs that support hardware MMU virtualization, Intel EPT or AMD RVI are required. This is pretty much available with every new physical machine from Dell, HP, or others. The following CPUs are supported: Intel Sandy Bridge or later. Avoton is not supported if that's a generation name. AMD Bulldozer or later are supported. Well, okay. So use a 10 gigabit logging network for FT and verify that the network is low latency. Well, obviously it should be fast. A dedicated FT network is highly recommended. So if you create a dedicated FT network, so if we go back here, and you have here, now this is the NIC for E6i2, and it is suppose connected to an external switch that is only dedicated. Now we have like 10 network cards. Obviously you would have two NICs or one NIC separately dedicated for just the FT traffic. So if that NIC is connected, or so from that particular NIC you would be connecting to a particular physical switch that connects to the particular NIC in the other hypervisors, and you would have a separate connectivity for just the fault tolerance, and that would be separate NICs out of the 10 NICs you have or 8 NICs you have, however, whatever configuration you have there. But they're just saying that to have a dedicated network configuration would be good. Why? Obviously the traffic. So we haven't talked about the primary VM, secondary VM. What do they really do all the time? So obviously whatever changes are happening in the primary VM are being replicated synchronously. So synchronously to secondary VM, right? Synchronous replication means same time replication, which means that so asynchronous and synchronous, right? So it would be synchronous means that the change happens here and the same time it happens here as well, and so they're just updated to the last second. And obviously for that to happen, it should be on LAN. It cannot be on WAN. If it's the cloud technologies and across the cloud and across the continent, you're replicating something that is called cross-region replication. So in that case, you would go for asynchronous on WAN, while synchronous with fast network, you can go synchronous. So it's all the changes are being copied at the same time on secondary VM, and that's why there's a zero data loss. When this VM goes down, the other VM is fully updated and simply fails over, and the users don't even know that. So the thing is that synchronous replication, if it is going on, that's a lot of traffic. Suppose there were 10 VMs here, right? 10 VMs on this E6i2, right? So if there are 10 VMs in E6i2, and 5 of them are actually critical. So 5 of them, and suppose they are SQL servers. Okay, that's a SQL Server databases. That's a lot of data, right? and they're busy machines as well. So 5 machines, critical, they are all SQL databases, and different applications are putting a lot of data inside those SQL servers. So whatever is being put here, or there are searches going on and there are files being opened and closed, so all that is being copied. So that's a lot of bandwidth consuming traffic that would be going from a primary VM to secondary VM. Maybe it's a file server, maybe it's a web server, or any other that is busy. So we, first of all, we cannot have, that's why we cannot have all the machines configured with FT. Second thing, it should be critical machines only. Third thing, it's going to need a lot of bandwidth, right? So that's why a separate switch here on the outside is needed, just dedicated traffic. Otherwise, it's going to create bottleneck in the traffic, regular network traffic, if its replication, synchronous replication is added there. So that's pretty important. And so that's why they're saying use 10 gigabit logging network for FT and verify that the network is low latency, and a dedicated FT network is highly recommended. Limits in a cluster configured to use fault tolerance. 2 limits are enforced independently, and there is a dash.max FT VM VMs per host. So this is the maximum number of fault tolerant VMs allowed on a host in the cluster. The default value is 4 VMs are actually allowed, but there is no FT VMs per host maximum there. So default value is 4, but you can have more than that too. You can use larger numbers of if the workload performs well in FT VMs. You can disable checking by setting the value to 0. So the thing is that it checks that if they are not more than 4, but you can disable that, and then you can have more virtual machines as well. And also the maximum number of vCPUs aggregated across all fault tolerant VMs on a host. So aggregated or combined, working in a combined fashion. The default value is 8. There is no FT vCPU per host maximum. You can use larger numbers if the workload performs well. Again, you can change the value here and have more machines, virtual machines, fault tolerant machines working with more vCPUs there. Licensing, the number of vCPUs supported by a single fault tolerant VM is limited by the level of licensing that you have purchased for vSphere fault tolerance. Is supported as follows. vSphere Standard and Enterprise allows up to 2 vCPUs. Actually, now it is Standard is also supporting, and Enterprise. Okay, so they are supporting with limited features here. So you have 2 vCPUs only available with the lower licenses, lower level licenses, and vSphere Enterprise Plus allows up to 8 vCPUs for the fault tolerant machines, because they will need more vCPUs. FT supported in vSphere Standard, vSphere Enterprise, and Enterprise Plus editions. So that's a good thing to know here, but obviously with limited vCPUs here. So the best benefit would be Enterprise Plus. Okay, so that said, let's go further and try to check out. It's normally and slot policy, admission control, it says here. So admission control makes it's good that we have disabled it, but otherwise admission control makes a problem there when we are really trying to configure the fault tolerance. Let's see if it will do that now, but before that we need to go further and check out some more. One more very good feature. Okay, so supports thin provision, yes, thin provision disk or thick provision, whichever you want to go for. Supports memory virtualization, hardware assist, and that is the more memory from the hardware can be dedicated to the virtual machine. Enhanced vMotion compatibility, EVC, if you want to configure. FT supports EVC as well. EVC simply hides incompatibilities of CPUs. One other good thing it does is that suppose you lost a VM primary machine and the secondary machine got created. But once the secondary machine got created, it needs to stay in that redundant mode, right? So primary machine is gone and we don't know when it's coming back. Maybe it comes back right away, maybe it doesn't come back for a few hours, and until then either the secondary machine can wait and be in a non-redundant state, or what it does actually is it goes for creating a new secondary machine and become redundant right away. So what's that's a good thing, that it needs to stay in the state of redundancy. So that's why secondary VM creates its own partner right away without waiting for the primary machine to come up whenever it's coming up. When the primary machine comes up, if it comes up, then it is automatically its network is disabled, so there is no problem with this. Why it happens? Obviously, it just needs an exact copy of this machine, right? So because it's a software, yes, so it can easily create an exact copy of this and start replicating. So it's gonna be this way. It's gonna start replicating to the new machine. So this will be a new secondary machine and this will be the primary machine. So but the good thing is, if there are 3 hypervisors, we have 2. If there are 3, then it will simply do that it lost the first machine and it can't stay non-redundant in a non-redundant state. It just simply creates another partner, which is a very, very good feature. If we go ahead, well, the rest is just saying that Vsphere fault tolerance creates 2 complete virtual machines. So it's a complete second virtual machine. Obviously, it's not like some portions of the primary are being used and for the other. Vsphere fault tolerance creates 2 complete virtual machines. Each virtual machine has its own .vmx, which is a configuration file, .vmdk, which is the hard disk file. And each of these virtual machines can be on a different data store. Well, it's kind of a must. If they're on the same data store, then it's a SPOF or single point of failure. And then Vsphere fault tolerance supports multiple processor. Yeah, it can support multiple processors there, and that's no big deal. Changes on the primary machine are not processed on the secondary machine. The memory is updated on the secondary. So the thing is that all changes are copied there, and the processing is used. The processing power is used for that. During a vSphere vMotion migration, a second virtual machine is created on the destination host. Then the memory of the source virtual machine is copied to the destination. So whatever the memory contents are there are copied to the other host where the secondary copy is created. Now remember that we just talked about it, that the secondary, when you failover, it then tries to create on the third host another machine to stay redundant if the first host doesn't come back. If it comes back right away, though, it's okay. So the thing is that the memory contents are lighter data. It's not heavy data, so it gets copied as well to the other machine, and then it starts replicating from the new primary machine now to the new secondary machine. And then checkpoint data. So in vSphere vMotion migration, checkpoint data is the last bit of memory that keeps changing. So checkpoint data normally is that how much data has been copied till now and how much data is remaining. So there's a checkpoint file that normally knows all that, and then it gets copied as well. There are files that are taking care of what is copied and what is not. The SMP FT checkpoint interval is dynamic by default. It adapts to maximize the workload performance and can range from as small as a few milliseconds to large as 100 milliseconds. So the fault tolerance fast checkpointing, it just when it's replicating, it's very fast, and the checkpoint file, which normally knows that how much data has been copied and how much is remaining, it's all in milliseconds. It's going on that how much data is being copied between the two primary and secondary virtual machines. It also just says in the next one that normally the universal unique identifier is known share.vmft and .ft generation. These are the two files that know that which host the primary machine is and which host the secondary machine is right now. So some files obviously are there to know that, and the share.vmft file, which is found on a shared data store, is the vSphere fault tolerance metadata file and contains the primary and secondary instance UUIDs and the primary and secondary VMX paths. So where do they exist, which host they are running on right now. Suppose the DRS moves them again, so now on which host they are. So there's a file that keeps a track of that. And then there's a fault tolerance feature for the virtual machine. So we're gonna try to go for lab now, and the lab configurations are in order for your laptop processor to be detected to the following. Do the following. No, it's not do the following. So shut down in order for your laptop processor to be detected. Okay. So there's a T-shoot here. Shut down both hypervisors, select all options for the processors, power them on. Why am I saying that? Because EVC is needed for doing this lab, and make sure all VMs inside E6i1 and E6i2 are powered off. Now go to EVC and check your Intel processor generation. So in order for the FT to work, EVC has to be detecting your processors, and if in case it's not detecting, so this is a T-shoot that can be done. Now what am I talking about? EVC. So where is EVC, and what is our processing there? Did it discover our processor or not? So let me show you in that. So I'll drag this machine. So first of all, is EVC really working? Oh man, I have to change that timing of lock. Oh yeah, that's a lock timing in my PC. Oh. And so first of all, this. Second thing is okay. So this is my, now this is the remote one. I just need to go to the power options and put this on battery power turn off after. So it goes to sleep, and then I have to log back in again. That's on battery when plugged in. Okay, when plugged in 30 minutes. Don't go sleep. Oh man, battery power. Anyway, so I'll just close that. Yeah, and connect. So first of all, are our laptops connected to E, V, and C? It's not E, V, and C, it's just EVC. So I'm going to go to cluster here and then configure, and there is VMware EVC. So VMware EVC is disabled, and this is needed for FT. I'm going to click edit here, and hopefully the underlying processor is, oh well, is it AMD Surface or is it
Intel.
Oh, Intel.
i7.
Okay, Intel i7, so it's not MIROM. First of all, if I go to Penrin,
Compatible.
those cannot be admitted to the clusters because it is not compatible. Okay, so Nehalem and Westmere. So that's the processor, Intel processor generations, and it's checking that the current underlying processor, which Intel generation it belongs to. Mine, my laptop belongs to actually Sandy Bridge. Oh, Sandy Bridge is not. Ivy Bridge maybe. If it, oh, there you go. So yours is Ivy Bridge, and it shows here compatibility succeeded. So it is now for, first of all, this EVC is not meant for the personal laptops here. It is meant for the servers like HP, Dell, and others, right? So the thing is that if some laptops it may not detect with any processor, any generation. So in that case, I was showing this slide here that shut down both hypervisors, select all options for the processor. What does that mean? Select all. If your laptop processor is not detected by EVC, then this is the troubleshooting. And when you say select all options for the processor, what does that mean? Let me show you that quickly as well. If you need to T-shoot here, oops, yeah, that in this VMware. So if you go to suppose E6i2 here, and I right click and go to settings, suppose your processor is not detected, then you go to VMware Workstation and you go to the, you have to shut down the specific machine, then you go to the processors here, and then you need to click this unchecked option here and this unchecked option. You need to select all three options for virtualization engine. In case your processor, laptop processor or desktop processor is not detected, shut down the E6i2, E6i3 only, and then because you need to detect it with EVC, right? So and without EVC, fault tolerance will not work. So then you select all these three options after shutdown, and then power it on, and then try to detect the, your processor, your EVC compatibility. So I'll select here. So we're here, and I'll just go for this full screen option. Okay, so it's Ivy Bridge Intel generation, and I'm gonna press OK. Right. So EVC pretty much fools the vMotion into thinking that the processors are all exactly compatible with each other for the 2 hypervisors or 200 hypervisors. Well, in our case, we have the same processor obviously, but EVC is actually needed for fault tolerance. So, well, this is back here, so this is good, and EVC is on, so we don't need to do that T-shoot that we were talking about. T-shoot, right? T-shoot in case your laptop / desktop processors are not detected by EVC. So some students in another college, 1 or 2 students actually T-shoot that there were 30 students there and all the laptops were not detected, majority of them. So they started testing things and they came up with this. Okay, so that's a workaround. Anyway, so it says power them on, power off, make sure all the VMs inside. Now go to EVC and check your Intel processor generation. So you have to just do this T-shoot in that case. Okay, I'll just put that. I'll put that slide there as well, but I'll put the actual T-shoot for EVC there as well. Then what do we need to do as the lab steps? So there is increase the memory of E6i 1 and 2 from 4 to minimum 6 GB. Ouch. Okay. And vCenter VM memory as 8 GB as well. Well, the vCenter memory could be lowered and then you can reach that 6 GB. So minimum 6 GB is needed for the 2 hosts that are taking part in this lab. And have 2 data stores available, one for primary. Well, actually we need to reach the first configuration, and so Sarfraz, your hosts are on 5 GB, right?
5 GB. 5 GB, 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 5 GB,
you have available 2 GB?
I think so. Let me just verify.
Actually, for this particular lab, only for this lab, we need this, and we can overcommit as well, which means whatever physical memory you have, we can still go exactly on that, or even
I'll have enough memory. You can do it, whatever you want to do.
enough.
Yeah. I should have. I think so. EXI 0. 17 GB.
Whoa, what is this? What is your total memory? 32?
32 GB.
Wow.
Yeah.
Okay, cool.
This is
Your vCenter. That's why your vCenter is so smooth.
5. 7 20.
So minimum
3.
6. So we need to shut down ESXi 2 and 3. And
Yeah. And 5. Yeah.
Please 1 more.
1 and Win is on.
Win is just a remote desktop.
2 GB. Yeah, 2 GB. Yeah, we can increase them.
Okay.
1 GB.
So I'll go for ESXi 2. Our VCSA is on ESXi 1, obviously, right?
Yes, ESXi 1. Yeah.
So we can mess with ESXi 2 now and shut down guest here. And ESXi 3, shut down guest. So minimum 6 GB, guys. That's for the fault tolerance. We tried it with 5 GB and it gave an error. We had to go up to 6 GB then in previous classes, actually much previous classes. So we found out the hard way that minimum this much is needed for fault tolerance. And with every update, they do keep changing the rules as well. So then we still keep discovering the hard way. ESXi 2, I'm just gonna click the edit virtual machine settings to change the memory from 5 to 6. 5096. Well, it could be some other number. 6096. And click anywhere else. Oh, 096. So it's 6 GB now, and okay, I'll start this guy first. And ESXi 3. 6096. Click anywhere else. 6 GB. Okay, we're supposed to be okay. Sometimes the new builds that we download may have some newer rules there. So then we go back to the documentation and then see that, oh, okay, so there's another rule here, a newer one. So once these two are on 66 GB and detected inside so let's check it out. Are both on the last dot. Okay, so last one here.
Those take time. I don't know why.
Yeah,
They take
starting
time.
services.
Yeah.
Starting service VMware FDM. So some services do take time, and also normally the memory in the production environment is much higher. So,
right.
Yeah, it's
right.
Okay, here. So Win01. Now, obviously, when they are fully done. Wow. So I'll refresh here on the top. And one more thing is that all the VMs need to be shut down. Wow. Yeah, I think so. Am I still able to? Wow, while they're starting, okay. I'll just power off all the virtual machines as well, because every inch of RAM is needed now for the fault tolerance. Fault tolerance is a very sensitive service. It just pops errors right away. Oh, I don't have, oh, did I click? No, sorry. That, oh, I don't have memory. And then you have to check again which nick and corner we can grab some more memory for fault tolerance. Okay. So all machines are.
Rule also. Amir?
You want to put an Affinity rule which you created
one of the rules of
Oh, yeah, the Affinity Rules.
Yes, you remove one of them.
Oh, yes, you're right. Actually, I need to remove all of them.
All of them
actually.
You're right, so it could give a surprise on any next lab, so thanks for reminding that. And I'll just delete this. The machines are off, the rules are gone. VM groups showing there does not do anything unless they are put on the rules. So they can stay or they can go, it doesn't matter. Oh, okay, now when I said oh, I should have said oh earlier, I guess. Now it did, okay. Win01 here, and we're good in terms of so I'm going to click the host, and if I could access, yeah, so out of 595, yeah, we're good. So I'll just go for the first thing is done, and 66 GB for the hosts that are taking part in the fault tolerance, and second thing is have 2 data stores available. We have 3, so we're good. And then there is turn on EVC mode. We just turned on the EVC mode. vMotion must be working fine. We did try that and it's working fine. DRS also did some vMotions for us. Let's have a new network adapter and new VM kernel port with FT logging enabled on both hosts, and assign them both to unique static IP addresses. So that's why we added the 10 NICs, because we can do that. And so what we need to do is that we're gonna go ahead for creating a VM kernel port. Again, this before we create the VM kernel port for vMotion, now we're gonna create VM kernel port for fault tolerance. And the rule for using the VM kernel port is that you need to set aside the static IPs for them, static or dynamic, whichever you want, preferably static. So we're gonna go ahead and create, so whichever hosts are taking part in this, the VM kernel port has to be created, and that many separate IP addresses. Suppose there are 200 hosts there, so obviously that many IP addresses need to be separated. And now let's go ahead and try to, so the first host, A6i2, I'm on the A6i2 here, and I'm gonna go to the configure option section of that, and I'll go to the VM kernel adapters. Before that, well, on VM kernel adapters, we have already 2 VM kernel. One was created by default, which we migrated to distributed switch. One we created ourselves, vMotion, that is still on vSwitch 1 because we wanted to know if the distributed switch and standard switch work together. And now we're going to create the third one and connect it to another vSwitch. But how many switches are there? If I go to the virtual switches area for E6I2 here, and if I drop it, so we have one distributed switch and one vSwitch 0 and one vSwitch 1. vSwitch 1 is actually managing vMotion. vSwitch 0 is, well, we took away the management network feature from there and migrated to distributed switch, but it still has one virtual machine here. So, and distributed switch has the management VM kernel adapter there. So we're going to be, I'm going to go back to VM kernel adapters, and first I'm going to create that network configuration to introduce this advanced feature into the host. So I'll go to add networking here to add the VM kernel adapter for fault tolerance. So we're going for this one, fault tolerance now, VM kernel network adapter, and click next. We technically can add it to the existing switch, but as a best practice, vendor best practice, I'm going to go for new standard switch. MTU, if you don't have any particular reason, then keep it as is, maximum transmission unit, and I'm going to click next. So I'm going to click 2 adapters there. I'll just grab 2 adapters. VMNIC2 is there, VMNIC7 is there, so whichever are there, it's okay. It doesn't have to be exactly 6 and 7 or 2 or 3. So I'm just grabbing the available network adapters. Next. So we need to name it something. We're going to name it FT, fault tolerant. IP settings, IPv4, MTU is good. TCP/IP stack, there's no dedicated TCP/IP stack for the fault tolerance, but well, we're just gonna select this fault tolerance. If other options are still clickable, this means that in future you can still introduce more features there. But the thing is, it will affect the traffic, network traffic. So FT should stay separate with its configurations. I'm gonna go for next here, and then either dynamic or static. I'll go for static. And what we have used, oh man, that's a bad thing. I can't move away this. So what we have used before was 10 and 11 for vMotion. So 12 and 13 we can use here. 12 and 13. And 12 and 13 we can use for the 2 machines here. So it's going to be 192.168.200.12. Subnet mask, we know that, 255, 255, 2550. Override default gateway for this. Nope, we don't need to override. We have a fake default gateway that is, but it needs a default gateway. So 192.168.200.12. Yep, we're good. Next. And I guess we're not good. Already used for 10 and 11 we didn't use, so it was maybe 12 and 13. Really, vMotion port virtual switch has that. Okay. Anyway, so 13 and 14. Well, obviously we would have done some paperwork already and planned it in a production environment. So 13 and 14, I'm going to go for this fault tolerance and finish. So on E6I2, it is now this fault tolerant VM kernel adapter has been added that will help run this feature on this machine. And we had to create another switch, and we have given, so it was 12, 11 and 12. This means maybe 12 or 13. Yikes, I gave 13 here. If I check the E6I3, it's 11, 12. Okay. So anyway, so 13, 14. 13 has been given here. I'm going to go for E6I3 and do the same thing and give it 14. 200.14 IP. So I'm just gonna click add networking here, and this is a feature. So next, the new standard switch with this default MTU, and next, and whichever two network adapters are available. Okay, 1 and 5 are available, so I'll just go for those. There it was 2 and 7. And next. So the rest of the steps are same. FT here, and fault tolerance logging here. And next, also 192.168, so it's 13, change to 14, and 255.255. Okay, so submit mask is given. Next, and finito. Alright, so recent task says completed. So the two hosts are kind of ready for the fault tolerance. Let's check out what else we need to do. Let's enable FT logging on both hosts. Yeah, they're actually it's enabled because of this thing here. And choose any VM in shutdown state. So we can enable fault tolerance on any VM that is powered on or shut down. It's in both any state. Better start with shutdown state, because as soon as you configure fault tolerance, it takes certain amount of memory to start the machine, and it loves to pop out a lot of errors, and then we have to go and run for it. What errors is this? What is that? So choose any VM in the shutdown state that is on shared storage. Obviously our VM is on shared storage, and we need to actually check before we start the T-shoot. Okay, before we start the fault tolerance on any selected VM, we're going to check a few things. Check which data store first VM is. Okay, I'll just add here which data store, which host first VM is. These two things we need to know, right? Which data store, which host, because secondary VM has to be on a separate data store and a separate host from where the first VM is. So we need to know whichever VM we are selecting, which data store and host it is on. There are some T-shoot steps here as well. If there are errors, then make sure that VM has 1 GB memory for its working or less. Well, we are, really short on memory, so the VM needs to be given lesser memory. Otherwise, you will see it's a very sensitive service. It just says, "Oh, I don't have this. I don't have that." So, yeah, we always give the virtual machine 1 GB, 1024 MB, right? Please check which data storage is on. Yeah, turn off FT, and then change the memory if you have to do it, and then turn on FT again. So if suppose you've configured the fault tolerance, you're about to see that how, and after that, when you power on the machine, it gives an error that, okay, yeah, the memory, we don't have memory. So then you have to remove the fault tolerance configurations and then put them back again. You need to have HA and EVC enabled, otherwise FT will not work. So HA is on, yes. EVC, we just turned it on. Okay, if we are still low on CPU and memory according to FT, then we can visit admission control feature of HA and turn it off. Well, we turned it off last time, so admission control is already off, because it always creates issues. Actually, admission control, yeah, in our case, it always creates issues for only our lab. In production environment, this is one of the most critical features, to be always on. Okay, when we turn on the fault tolerance, it might say that, hey, turn off HA and then I will turn on, right? So I'll just still go ahead while HA is still turned on. I'm gonna go ahead now, but let me check the current machine, the data store, and which host it is. and then I'll go ahead and if the error comes, then we'll have to come back and temporarily turn off HA and then install FT and then later turn on HA again. So if I go back to this, so we can go for a lighter machine there because any heavier machine might not be suitable in our specific environment for FT. So if I go for VM04 and I need to know the VM hardware or especially the memory of that, right? So I need to click this option here to know what is the memory. 1 GB. Okay, we're good. First thing. Second thing, it is on ESXi3. Third thing, which data store it is on. So I'm just gonna go up to the data stores for this virtual machine, and it's on DS1 LUN1. Okay, so I need to open another notepad, and VM04 is on ESXi3 and DS1 LUN1. Has 1 GB memory, which I don't need to write, but anyway, okay. So DS1 LUN1 and ESXi3, got it. Now I'm just gonna right click on VM04 while it is shut down, while I also make sure every other machine within the cluster is shut down as well. So I'm gonna right click here, VM04, and go for this fault tolerance and go for turn on fault tolerance. So DS1 is our primary. Now it says here turn on fault tolerance, select data stores to place the secondary VM. So I'm gonna obviously place it on the data store other than the one where the primary is. That's the first thing, and it says compatibility check succeeded. Actually, we know that there's the primary one's disk. If I select that, that's not a good thing. The compatibility check succeeded. It should just say, whoa, what are you doing? That's where your primary machine's virtual disk is. So that's not good. It should alert here. Unless they are technically saying, so there may be some companies which may not have space in any of the data stores other than the one where the primary is. Smaller companies, right? And they know the risk already. It's a SPOF then, it's a single point of failure. Anyway, so they are technically allowing it. So in previous versions it used to just say no, you can't do that. Okay, I'm gonna click next, and so it was on ESXi3. Yes, it's showing ESXi2 now, which is good. It is only showing ESXi2, which is good. Next. Well, so I'm gonna click finish here, and this is for the secondary machine VM. We have selected all this, and I'm gonna click finish. So what does turn on fault tolerance in the top recent task says? Registering secondary VM with primary VM. You can see that the icon also changed for the fault tolerant machine. Now I haven't started it because the real game starts then, and we know that can we even configure it or not. So it totally depends on enough memory. Rarely it's the other features. So first of all, VM04, and you can see primary here, but you cannot see secondary, although it created that, right? Where's the secondary here? So we have to go to VMs and templates, this one. Actually, sorry, what did I do? We need to go this view, ESXi2. If I click this view here and then go to this view, VMs on ESXi2. So which VMs are on ESXi2? And I see there it's VM04 secondaries on ESXi2. And if I go ESXi3, primary is on. So it shows primary and secondary in this view. ESXi3 and VMs, you see this. So, well, what we see here is that ESXi3 has our primary. and exercise 2 has our secondary. If we go to, now is the time to check how much is the memory and can we power it on. So I'm going to right click on this VM04 and power on. Wow. Okay, the available memory resources in the parent resource pool are insufficient for the operation. Ouch, really? Okay, what else is on here?
Sorry to interrupt. It's like now for sure we need something beyond the 32 gigs as far as memory resources. I think, right? And we go back to the thing I once said that 64, right? Gigs.
I wish colleges would deploy these kind of machines. And
it'd be really nice. Yeah, it'd be really nice.
It would be really nice. You're right, actually. And we were able to do that easily with 32. Easily means not easily, but it is doable with 32 GB. But if 64 is there, yes, we can wish. And I know I've been working with multiple colleges, very big colleges as well, with big budgets. And this was the biggest thing they did not do that increased the memory of their machines. Other than that, they would put that money to anywhere else. So I don't know what their vision is always. So
I was looking online and Amazon, and they got like renewed servers, and I found even one with 120 gigs for like $700. It's like, what? Are you serious? Server equipment for that price, and then like a couple like 600, 300 gig hard drives. Yeah, I mean for Amazon, yeah.
There are many cheaper servers there as well. Cheaper servers. Well, it has to be new, because for the newer courses, some of the older servers we would be stuck with. So obviously we would do our research, and if the newer servers are there, definitely they should go for that. Now, 6 GB is also kind of so I'm gonna go for the cluster here and check out the admission control again. Configure, and so availability, and edit, admission control. I'm sure I disabled it. Yep. So all the resources are actually available for us. Other than that, what else is eating up that very less memory we have? Nothing. All the machines are off, and this one I don't think it has a operating system inside.
Yeah, no operating system. Yeah, no operating system. It's a blank machine.
Cool. And well, overall memory, if we check, and so this is our VMware workstation.
Right.
And that's your machine. And I'm going to taskbar performance 28. Oh, we still have actually.
We have 4 GB.
We have 4 GB. We have played 2 GB more.
Actually, we have more available. Wow, man, that's good. Well, we can just increase that. So on which machine it is working on right now? It is on data store. Oh well, host. It is on. I'm gonna go to summary. It's gonna show me the host here. E6i3. Hardest 10 GB, 1 GB, 2 CPUs here. So it's the memory resources that it's saying. Let me just increase 1 GB more. 6 GB. It used to work easily with 6 GB. And you still have more, so that's going to be another push towards that. I'll just increase it a bit more. 1 GB more, 7 GB. The FT services, right? It just even if there's enough memory, it just says, "Oh no, I'm not running. Do this first." Well, it is censoring. Yeah. So I'm just turning on both machines and making it 1 GB more. But the steps are the same. The thing is that we can also just get those machines for ourselves at home. I had to purchase machines myself at home, bigger ones a bit back, and then I did all these labs on my machine until the newer software came and my machines became old again. Okay, it's 6.9, yeah. Okay, but obviously here. Oh, admission control. Site 2. Don't tell me. Okay, it started here. And that arrow should go away from here as well. Yep, gone. Okay. So now it is, well, this is the site 2. Let me just shut down guest. I think the overall 2 GB left is also not acceptable. Normally we just overcommit and it works that way as well. I think you have given 17 GB to vCenter. Yes, it deserves that, but that's too much generosity for the current environment.
Yeah, I think so. I gotta. And if I shut down my VXSI one, it'll take me at least 45 minutes, up to 15-20 minutes to start off.
It's gonna take time. Yes, you're right to set it up. Now, what I can do is 7 GB. Really, it's okay. 7.2 or 7.5. I will go for that. Wow. Okay, 7.6 is 7.5 here.
Okay.
So the other one is up already. Yeah, 17 GB is yeah. You can maybe it's not maybe you for the vSAN. We actually need a third hypervisor.
Okay, so I will do that calibration.
Yeah, if you could go down to 16, no, not 16 actually, 12 or 13.
Okay.
So only the start is the painful area. So if you start like before the class, maybe 10 minutes before, 15 minutes before, we're good then. Or if you suspend the machine, it's just there. It doesn't start all the sources. They're already started. What I mean is. Okay. So
That'll take some time. At least, right? Yeah.
Okay. This is okay. So now, okay. So it's 7.1. And oh yeah, so it does that too. FDM is at the, okay. If I go back here, Win01, yeah, it has to still detect that. Other one, I'll click refresh. So although the final service is not started, it just successfully detects the 2. So that service might. Now, once this is detected, then for these two machines, and I need to power on. I could also try it on the VM03 and remove it from VM04 if sometimes it happens that the machine itself has some issues detecting. So I'm just going to try to power on, and okay, that worked good. Okay, so primary, it's starting, and virtual machine fault tolerance state changed. Yeah, it's VMware Tools is not installed, but start fault tolerance secondary VM. So it's trying to start the second VM as well. And yeah, okay, nice. Okay, so now even the error is gone because it was waiting for its redundant partner to start, right? I will go for that view. So E6i2 here is for end VM. So the primary is on E6i2 by VM04, and E6i3 with the same is VM04 secondary and VM04 primary. Okay, so that's very good. Now the first thing we do for fault tolerance is the crash test. Yay! Okay, what's a crash test? We simply crash the machine that has the primary. We simply crash the E6i that has the primary machine, and we are expecting that status to be given to the secondary. So E6i3 has the secondary, and it should turn to primary. Automatically, the status should turn to primary when it loses connection with the primary. So secondary becomes primary. That's what we are intending to see now. So the plan is that I'm going to crash the E6i2, and I am expecting the VM04 to change the status from secondary to primary. And then it's going to be, proven that, okay, FT actually is configured properly. So VM04, E6i2, bye-bye. So E6i2 is this one. I'm going to go there, and what's the best way to pretend that it's gone? So shutdown guest is a proper way to shut down, but power off is the dangerous way. It's like pulling the plug off right away. So that's power off, and I'm just gonna power off while that poor guy just started. So I'm just gonna power off the E6i2, and okay, that's good that it confirms. Are you sure? Okay, so power. So the crash has happened just now, and we need to. So E6i2 disconnected became secondary. Yes, disconnected. Yes, that is also true. That was instantaneous, and E6i3 became primary. Okay, we're good. So, but it has an alert here. If I click on that machine now, it is still started. If you had an operating system, obviously with more RAM, we could do it with the operating system as well, or you can do it with the operating system. So it is still started. It's not like it's powered off, and it has changed its status to primary right away. That was instantaneous. And the other one is showing secondary. This on E6i3 now it shows primary, but there's an alert that it is not redundant anymore, right? It's just a single machine that is there. So fault tolerance state has changed. It just says that, and so yeah, that's what we were expecting, that it should just change the status, and it's not redundant, so it's just giving the error that, hey, I'm no longer redundant, where's my partner? Now so this is good. I mean, the crash test simply changes, so fault tolerance really works on the crash test. I'm going to power on the E6i2 again. And the status, the error should just change back to green, like as soon as the partner is detected. and oh, that's been workstation. Gas run system power reset. Oh yeah, that we just did that. So. Ooh. Fail to decompress. Yeah, this is blue screen of death is actually pink screen of purple screen of death here. Fail to decompress this. The SXI2 is kind of unstable, so I'm just gonna send a shutdown here and then start it again. So DRS, then Affinity Rules, VM overrides, and fault tolerance. These are what we have tested today, and but we had to just increase the RAM, which is VMware is really, whole environment is very RAM consuming. So okay, so it just says there no port for remote debugger, escape port. It says CPU has been disabled. So 7.5 gig 2 CPUs. The other one is by now started. It's the SXI itself. So fail to decompress SB failure. Okay, so that's so we gave enough memory, and if I click escape here, it's gonna start debugging, and that's kernel debugger. Create a live core dump without crashing system. Display vim kernel log. Display content of symbol. Okay. I'll just try to reboot. The crash test didn't like the crash test. So that's where the error comes. Really? That's what happens with the live environment, that live errors do come as well.
Maybe shut down the VM and then restart the ESX02 without the VM running.
So yeah, shut down the VM itself, ESXi2.
About the gas VM is what I'm calling going. That's running the fault because of the fault tolerance, right? The CX03 is the one that's primary right now at the moment. Because it said disabled by the guest OS.
So yeah, you're right. It makes sense. If I just go ahead and power off the actual VM. Oops, did I click no again? Yes, it does make sense. You're right. More volume. It's the guest. Okay, and then. Oh, you could have. Yeah, it was just a reboot was the only way ahead.
It's funny how guest OS would have control over the CPU just like that.
It is the first time I'm seeing that. It doesn't happen like that ever before.
Oh, okay.
This is something specific to SXI2, but let's see. So yeah, it Oh,
There it is again.
Yeah,
Is it still on? Is it still on?
It's quite unstable. Even before that, it was not very stable. E6i2. I think in previous courses I had to reinstall one more host and add it, and because of some corruption happened in the E6i2, instead of troubleshooting, that time would have been taken out of. So I had to just add another host instead of this to do all the labs, rest of the labs. This is not really. So if it could be that now enough RAM is not available for the host operating system as well. So it could be saying that, hey, that's it. Why are you overcommitting? Although this never happened, I think this E6i2 itself is unstable or corrupt. I can just check it out by, putting it back to the same RAM, because FT is tested, and if it is because of the virtual hardware changes that we have done that it is reacting. So I'll just take it back to 6.2, just 6.1. That's the only change we did here. So sometimes the kernel doesn't like the changes. Otherwise, if it is unstable or corrupt, then we just have to have A6i4 instead of 2 to carry on with the rest of the labs. It's VM kernel loaded, BROS, Pro, CFS, okay, crypto, VDM, Shaper, Sun, RPC, NFS for client, VFAT, THWAP, OBJ. It's going further.
Seems to be working. Yep.
Yep.
So it's the not enough RAM kind of thing.
Yeah, maybe the guest host. My Windows is dying off.
But that 17 GB is that would really.
I'll change it.
But otherwise, your environment is perfect. Yeah, we're good. But so we did the crash test for the FT, and that's what it was supposed to do. Yeah, so yeah, it's gonna take time on this one, definitely. So other than that, I also wanted to show here on the primary, the current primary. If I right click on top of that and go to the fault tolerance, so there's a turn off fault tolerance option, there's suspend fault tolerance option, and there's a migrate secondary. So you can just move the secondary to some other area as well. Also, if we go to, this is the A6i3 on which the current primary is. If I go to 2, where the secondary is now, which used to be the current the previous primary. If I go to the fault tolerance here as well, so it's not showing any of those options yet. So the thing is that when it is perfectly configured and working fine, so you have just few more options here. Test failover is there, test restart secondary is there as well, and those options really help to simply test your environment, that is it really working. And whenever, suppose for 2, 3 years, 4 years, the failover doesn't, it is not needed, there was no failure that happened because of which the failover could be triggered. So you could keep on testing that as a policy of the company to check the failover twice a year. In banks, normally they do check failover twice a year for pretty much every server. So one weekend we just sit there and we failover everything to test only. So yes, that you can do with the virtual machine environment as well, and test restart secondary as well. So well, that's
I would just confirm one thing. That means if we had an extra EXSI host, and when we bumped out EXSA 02, it would create a secondary on the other EXSA hosts also, right?
Exactly, it will. And
Yeah, it would.
yeah, the
Right.
students
Okay.
have tested it in their office environment by actually getting this test servers there after fighting with the boss, and try to do that. So yeah, it works fine. Okay, guys. So this is it, and see you next Saturday. And I'll try to fix my machine as well, so I could run on my machine. But yes, it works. FT works fine, and you can just try it on your labs as well. Okay, so
Bye, everybody. Bye, everybody.
Bye.
Bye-bye.
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 And thank you, Sir Frost.
Anytime.
Anytime.
All right, I'll just disconnect.
Yep, you got it.
Yep, you got it. I just, yeah.
Thank you. All right, bye-bye.
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 So, just right click and shut down.